Hello everybody, hope you've had an amazing weekend so far. It is your boy Trix, and today we're going to be doing some more Ziglings. I'm very happy today, as we're in autumn, we're using Neovim, and we are going to be using Dusks today. I know that's very hard to say, so hopefully that comes up. I'm going to be using my Dusks today. It's been so long since I've used my Dust. I always roll on my DOS and S12s because I'm always using my Samsung Galaxy Buds and my Bose headphones, and I never get to use these ever. It's always oh, I always get the S12s or I just get random gear. But this time I actually got my DOS, and I genuinely enjoy using these every time I pick them up. It's like a miniature headphone. It's so good. Sometimes I just get lost in the music when I'm listening to my DOS. But anyway, a little bit of setup earlier. So we've got Neovim up. We're going to be doing number 63, which is labels. And we're going to be working through it here. So let's start. Okay, so it's kind of like a jump go to in not assembly in no, is it assembly? I know one language specifically has that. Don't remember which one it is. So this is a foo, make 5, which is the label. Then you say 5 is 1 plus 1 plus 1, then break on make 5 and return 5. Okay. Fair. So you're assigning two, so you're making a U8, which is bar. You got a label of 2 loop, which is a while loop true, which has another while loop that breaks 2 loop and returns 2. Otherwise it returns 0. So this should assign, so because it's breaking the outer loop, it will return 2 and assign it to bar. Yeah. And without the breaking having been called, yeah, that makes sense. So we've got my while label, which is a while true, and then continue my while. Okay. Yeah, that makes sense. Okay. So this thing, for each wanted ingredient, you check want it, and if the required ingredient is equal to want it, you'll break and return true, otherwise you'll return false if it never reaches this condition. Then you'll break from the outer loop if found is equal to none. So if the found is equal to false, you'll break the found loop, which is assigning it to meal. Technically speaking, your meal would then never have anything assigned to it, right? Because you're saying you'll just break on found loop if you haven't found it. And you're not returning found in this. Yeah. So you want to break and return found. Oh, is it on? Let me just see if this works. So if that works, then I'll do the challenge in here. Mm-hmm. Would it be menu 2? No, menu 1. I didn't save. Ziglings. Let's have a look. It's labels. Am I dropping frames already? No. It's just internet being bad. Sick. Mm-hmm. Oh. Okay, so I'm missing 2 bits. Okay, that makes sense. So here, you want to return food. And then here, you want to return menu bracket 1. Mac and cheese. Oh, I chose chili mac instead. Whoops. That's supposed to be menu 0. That makes more sense. There we go. Now, the way to get rid of the found I'm pretty sure, is you can do this, then else on this, you'll just continue the food loop, and then this one you wouldn't need. Break on true, else continue the third loop. Oh, hang on. Found, okay. So found, else, false, right? Then if not found, continue. Otherwise, so you wouldn't need found. You would just do continue food loop here. Like that. Ooh, I don't know. Let me just see how much there is. Okay, cool. So not that many. Okay, so my result is a tuple. Print as binary number 0 pad, right align 4 digits. So it'll be A plus B equals my result, and then S being true or false. Yeah, that makes sense. So overflow would be +1. So 1, 2, 3, 4, and 1 here. I'm just basing this off of A plus B, right? So 1 plus 1 is 0. So let me write this out. So in this column we would have 0. Bloody hell, 0. Then we'll carry the 1. So we'll have a 1 here, right? Then 1 plus 1 is 0. Carry the 1. Then 1 plus 1 is 1. 1, 1, 0. Wait, what the hell? Yeah, 1 goes there. 0, carry the 1. 1 plus 1. Oh. 0, carry the 1. So they're like that. Because 1 plus 1 is 0, carry the 1. 1 goes down. 1 plus 1 is 0, carry the 1. You got 1 plus 1, which is 0, carry the 1, and then 1. So down here, 1, 0, 1, 0, 0. 1, 0, 0, 1, 0, sorry. Is that right? 0, 1, 0, 0, 1. Yeah. One sec, I like this one. Like that. There you go. Mm-hmm. Oh, okay. It's not a it's not a method, right? It's just fetch the most be. I don't know why my LSP is turned off. That makes sense. Is that 15? So it's not treated as a field. Is it treated like a method? I don't think it is though. Okay. Is it at this narcissist dot? I wonder how. It's built-in too, right? How does it... No, not that one. Oh... It's treated as a static? If this works, then I'm just going to explain what a static is on this. Can't see it in type, that's fine. So the reason that that's not working is because, not this, that this wasn't working is because it's treated as a static method on there. So in Java, for example, you can name a method as static and you wouldn't have to initialize the variable, I mean the actual object. You could just call the class name and then execute the method by just calling it as you would on a normal object. So even this narcissus object, let's say, has this method on it, but it's not public. It's only static. So because narcissus destruct has this as a static method on it, and it's not tied to the object, it's tied to the struct. You call it on the struct. I think that's what that means. Is of type void. Okay, so does that need a question mark on there? Oh, field type. There's a field type? Wait, what? It's type, okay. Interesting. We're slowly but surely getting there. We're at 66 and there's 103. So I'd say for the... It's number 5. So for the 3 weeks that we've been doing this, it's been going okay. So it's one sec. I want some like less upbeat music. I need something that's like lo-fi. There we go. If something's upbeat, I lose focus and focus on the song instead. Okay. That makes sense. So there needs to be a U32 and this needs to be an F32. Mm-hmm. So then if I run zig build, and types are comp int, comp time float, U32 and F32. So because you're saying that they're constant, they don't exist when you compile. They only exist at runtime. But because these need to be mutable at runtime, yeah, these identifiers don't exist at compile time, but the actual values are compiled into the application. Whereas with this, because at runtime you need to know the type assigned to a var, because if you want to change that later on in the application, so with a const, it'll just allocate that memory up front and just knows that, oh, this is const, it'll never change, it'll always be this value. Allocate this at compile time. That's fine. But with a value that can change, you need to know how much space that value could occupy in memory if it were to change, if we were to add or take away or divide or whatever. So you need to know the maximum size it could occupy before you can start modifying it. If you don't set that, you'll get a compile time error. I mean, a runtime error, sorry. That makes sense. That's why there wasn't any LSP highlighting that it was wrong, because technically it's not wrong. It's just that if you decide to modify that later on, of course it's not going to work properly because you have no types in there. That makes sense. Comp time. Okay. Mm-hmm. Makes sense. Ooh, okay. So technically speaking, you could shoot yourself in the foot if you modify the bar to, but because you're saying it's a compile time variable, you're letting Zig identify identify it what type it is as at compile time. So okay, so this is gonna need a whoops shift tab. There we go. W in comp time. So okay, then you got a bar one that has type, so that's fine. Built-in is like the it is just comp time, right? It's not at comp time. Yeah, it's comp time. Cool. A compiler built-in is like a print statement that only operates a compiler. To use them to develop compile time logic. Try and commenting the sign and playing around with it. Copy it, move it, see what it does. It's fine. It's fine. It will just tell you what the value is at that time. So as it executes, if it compiles, it will just compile with the value that it knows it will be, because at compile time, it won't need to actually run. It will just see what the value is as you modify it and show you what it is. So if I were to hang on. Okay, so we know it's currently 0. If I chuck it here and uncomment it, run it, then zig build. At compile time, you'll have a compile time log just saying, oh, this value is this. Oh, that's weird. Oh, yeah, never mind. Yes, makes sense. It'll fail because it's an error log. It'll see it, but you'll still get your value as 3 because at compile time, it's already incrementing that count, right? And because this hasn't changed, this variable isn't being modified by someone else, it can just implicitly tell that, okay, cool, it's going to be 1 here, 2 here, 3 here, and then when you log it out, it'll show us 3. So when we remove this and did not want to close, and it's very used to closing, and you're right, it will just say, oh, that value is 1, 2, 3, 4. So if we scroll up a bit, oh, it's just doing, sorry, 1, 2, 3, 4, A, B, B, C, 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 D, D, D. Wasn't paying attention, sorry about that. That makes sense. Mm-hmm. That makes sense. That's just scale, right? Yeah, that makes sense. Oh, okay. B. Could be B. I think. That should fix that. Yeah. Oh, I felt that. I felt it coming. I was like, no, I'll power through it. Nope. I thought I heard someone calling for me for a minute. I'll just keep this out in case I was called. The size needs to be known at compile time. So this just changed the comp thing. There we go. That's the size of the array to be type T. It's not 2, is it? No. Which sequence for period returning? Okay. It would be size, right? No. The U size. I think it's U size. Then this should be a size. Then in here is size. I don't like that. I think it should be size or U size on that line 9. Oh, it passed. Interesting. I wonder, is it because that at compile time, that size is known, it doesn't get changed again because it's only called once, so specifying it as size should be okay, then because your sequence is being set to size T is again, it's alright to do? Is that what the... I just want to see what that does in this one. It's 69, right? Size T, U size, yeah, it does the same thing. Interesting, okay. It's just like using generics, essentially. Oh, I realize some people might not know what generics are. In Java, you can do something similar. So if I go back one, where you have comp type T is a type, you can do something similar in Java where you specify your type as extending something if you want it to, or if it doesn't extend anything, you can just do type T for a variable, and then when that variable actually gets passed through on your method constructor or whatever, as long as that variable, as as long as that variable, the thing that you want to modify on it, is similar between everything that you'll pass through it, it will just be fine. So let's say you have you're accessing the same field or same method on there. As long as everything that you pass through to that function or constructor has that same field or same method, it will work fine. If you pass something to it that it's not expecting, and if you pass something to it where those things that you're trying to modify or trying to look at don't exist, then it'll throw a compile time exception or compile time or runtime exception that you're using a generic that doesn't conform to the classes or objects that you're actually passing it through. That's not the exact wording of the exception, but it's kind of similar. But anyway. Has declaration has field to tell pulse moving passing start rabbit duct and rabbit duct both contain level 1 requirements of squaring and specific declarations. Yeah, that makes sense. That makes sense. Yeah. Here, whoops, it's waddle. Oh, it's my type. The only thing that I don't quite like about this is I think under the hood it might be using something like reflection because it's doing string matching, where after a certain amount of time it will be fast doing it multiple times because it'll already be cached. Like when you execute a program lots of times, there'll be certain optimizations that the language can do or the compiler can do that during runtime it can just know that, okay, cool, this is already on this object, and all objects that get passed through to this that are like this will have this object, so we don't need to do this match again. That's fine. But on the initial start, that's going to be very slow. The type of will probably be fine. It's just checking the actual type of the struct. But the has declaration model and quack being string matches, oh, not that great. That's going to be slow first time out runs. I know lots of people don't like inheritance and stuff, and I do genuinely agree. Inheritance, when you don't plan to have inheritance, is pretty bad. But if you're going to be sharing methods like that, you might as well have like not even like normal inheritance, which is like extending an object. Just have a custom interface or something. Just like one interface that just has the method declaration there, so that you know every other class that implements this interface works that way. Because then you're not sharing logic upwards or trying to execute logic from one method up. You're just saying, okay, cool, this method has to exist on this child class. Otherwise, it's not a valid child class. I think that's fine. The whole extend stuff, I do 100% agree. You should not be sharing logic up, and then if that eventually changes, then everything else downstream will also change. And then you need to make sure that you're always calling that same method again upstream. It's upwards. It's very annoying. If you at least have interfaces, you can have all of that logic separate, or like default methods that can't be overridden, which is fine, because then you never need to call them downstream. It's just that you might have similar code that is executed downstream in those shared methods, like with Waddle and Quack, but at least you wouldn't have to do this type inference. I understand why it's done, obviously, but there are better ways to do it in other languages like Java and C#, where you have interfaces. I know Rust also has interfaces. I haven't seen them in Zig yet. The interface in Rust is just an implementation. Oh, what? I missed one. What line is that? 126? What the hell? That exists. Did I not say it? There we go, I just didn't save. That makes sense. Okay. Oh, cool. So it is using reflection. Okay. I know in lots of languages they don't talk about reflection. It's nice to know that like other languages are like using reflection. I know Java was probably not the first language that started using reflection, but it's very useful. I don't know if you can do if there's a reflection API in Zig though. I know in Java it's like very commonly used in like Spring for and JUnit for like annotations and stuff. Oh, cool. So it's just an inline for. So. Oh, whoops. It's 4, and then I need to grab fields, right? And then it's fields, and then you need to extract field, I think. So after syntax looks like would be nice if I did like that. Yeah, I think that's it. I saw what it was in 65. 65 was... Ooh, Jesus. This is a lot simpler, yeah. Because then you only have to do the type info once, and then you can just have an inline for to do all of that. Because then you're only type matching. You don't have to worry about this needs to be this or handling that stuff. It's very nice. Reflection does make things a lot easier. It's just not fast. Yeah, that's 72. Cool. So you've got a pointer, const 3, so an array of 3 variables, with each variable storing 5 U8s. So, okay, that makes sense. So you got a string, you've got 3 strings, which can be a variable length. Then in those strings, you're storing a U8 that occupies 5 blocks in memory. And then when you inline your foo, which is that array. God, okay. Jesus, that's okay. You have foo I, okay, and then that's grabbing that. Then you have foo I plus n, and then you're substituting into there. So you're doing a string concat on foo I, which just places s into that position with that number. No, it doesn't do that. Oh God, what the hell? I have no idea what line 10's doing. What the hell? Yeah. That makes sense. Yeah. You may wish to loop over each instruction in showing at compile time. Please fix this. Okay, so this is just saying you've got your instructions. You want to change this to be an inline while I is less than instructions.len. Then in here, you haven't extracted digit yet, so I'm assuming you want to grab digit. Oh, hang on. It is, yeah, there we go. So it's I plus 1 here. There we go. It's your condition to increment, so it's not I plus 1, it's I plus equals 1. There we go. Then this goes to 0 from the start. Can you figure out why we subtract 0 from it? No, I don't know why you're subtracting 0. Mine. Digit instructions? So instruction will grab 3. Okay. Then you got 0 minus 0. Okay. I don't think I'll know until I actually see the output, actually. Jesus, okay. That's pretty cool. What's the plus 1 minus 0 doing? Minus 16. If it's not I plus equals 1, what is it? It's not value, because value is incremented here. It's not digit, because digit gets assigned here. But for some reason, instructions plus I plus 1 minus 0 is throwing me minus 16. Why? 72? Yeah. Yeah, that makes sense. That makes sense. Plus equals 3 plus 1 minus 0. So, minus 0. Why are you doing plus equals 3? Each instruction plus 1. Oh, I'm so stupid. Oh. Okay, hang on. Let me just explain this before ending the stream. Okay, so I was like, oh, it's just indexes once. No, it's a string. It's got multiple indexes there. Each instruction is 2. So you've got plus 3, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So let me just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So I plus 1. So if you start at 0, I plus 1, you get to 3, minus 0. Minus 0. Why is the minus 0 there? I plus 3. Okay, I plus 1, minus 0. And then that becomes your digit, right? Which makes sense. You're assigning it to your digit. Why does minus 0 go? Bar digit string. Is it assigning a 0 there for no reason? Is it putting a 0 there for no reason? I'm not sure. But the plus 3 now makes sense because you're going up 3 positions each time, right? Because you're starting here every time. You're starting on the actual instruction value, which is why it just does I, because it's a 0. That's 4, 8, 0, 1, 2, 3, 6, 9, right? That makes sense. Okay, so if I just write this and then zig build, I still don't know what the minus 0 is for. $26. That makes sense because you're just doing manipulation here. So you're just doing 3, right? So plus 3, so you got 3. Then times by 5, 15, minus 2, which is 13 times 2, 26. The minus 0 I'm not sure about. Oh, I really wish I understood Chinese. I think this is Chinese. Sorry if that's offensive to anybody. It looks like Chinese. It doesn't look like katakana or hiragana. I think that's Chinese. Some symbols in Chinese and Japanese are very similar. I really wish I understood what this meant here. Why you're doing? I'm assuming is this section here that's talking about the minus 0. Damn. Anyway, thanks for watching. Like, subscribe, enjoy the rest of your week, and peace.